Welcome to this tutorial. I'm standing in front of the Jülich Supercomputing Center, which hosts, besides a couple of the most powerful supercomputers in the world, the TOR database. Let us begin. In this tutorial, I will present to you how you can make use of the so-called REST interface of the TOR database. REST stands for Representational State Transfer and describes a way of interacting with the website through arguments in a URL. So you don't need to click and point with the mouse, but you can actually control the response of the website via the URL, which means you can use that in your own programs. Let's begin by logging into the Join Web Interface again. Actually, you don't really have to do that in order to use the REST interface, but it just makes it easier to access. So I will just log in again under my account. Remember, the URL is https join.fz-jülich.de. Okay, so here we are. So in the last tutorial we looked at the map interface, the interactive GUI. This time we will click on the right button here, which takes us to the base URL of the REST interface. And in fact what you see here is a documentation. So if you want to access the REST interface directly, you would have to use that URL here. So join.fz-jülich.de/services/REST/surface data, and this will take you to this documentation. Just to demonstrate to you in principle how this REST type command works, let's actually look at a more useful query like search query. So if you want to search for stations or time series with a specific characteristic, you can use the so-called search command. And as is demonstrated in this example link here, basically what you do is you just append to the base URL join.fz-jülich.de services/REST/surface-data. You just append the command that you want to execute, and in this case this would be search, and you add another slash here. And then you have a number of query options that you can specify, and these are actually very versatile. There is a list at the end of the documentation which tells you which kind of queries you can make to the database. And in fact it's also shown here. Some documentation is also shown here. So let's try this out. So if we want to do a search query, search, and we want to find the station, or let's say all the time series that are associated with the station Westminster again, you can just type in station name equal London Westminster and submit the query. And indeed what we see here is a response. This is the so-called JSON format. There will probably be another tutorial to explain this to you, but there are many programming tools that make it very easy to read this kind of web response. So for example in Python this would be the JSON library that you import, and then you just simply say json.loads, and this will basically convert this kind of string response into an actual Python data structure. In this case it would be a list of lists. So what we see in this response are basically a couple of fields, and they look a bit cryptic to you, just as they are shown here. You will find a number which indicates the time series number, in the database, and this number is important later on to actually retrieve data directly from the database. You will see the network name, in this case it's airbase, station identifier, and then the parameter that's coded with this number here. So here we have NO2 data, then here we would have relative humidity. Again, note that this stems from the reanalysis simulation. Then we have NO, a measured quantity again, pressure, carbon monoxide, planetary boundary layer height, U component of the wind, ozone, NOx, temperature, total precipitation, NO2, one way, humidity, cloud cover, and finally the V component of the wind. Of course, we can add all kinds of other query arguments to this query. So if we just remember, for example, the NO series here, remember this 113357. If we just query for anything that has a parameter name equal NO, you see only this series coming up. We could also add a list here. So if we want to search for ozone and NO, we can do it like this. You see the two results popping up. Of course, querying an individual station is only one thing. You can also query, for example, all stations in a given country. So let's do station country equal United Kingdom, and we want to again query for NO and ozone, but we also want to query stations which have a population density, and we need to say station population density, which is between, let's say, relatively high density, so 40,000 and 1 million. Enter, and here we go. Oh, actually, a few stations popping up here. You can also specify in the search query, you can also specify which kind of output you want to generate. So, as I told you before, the standard way of outputting this is to return these 4 fields. And let me first show you what happens if you do as dict equal true. Then you actually get a different response where you get a dictionary, so it's a list of dictionaries. And here every entry contains basically the tag name of what you find in the answer. So in this example here, you will find the ID, which is the time series ID with a number, the network name, station ID, and the parameter label. This of course makes it easier to read for humans, but if you query thousands of stations, it's of course less efficient because you need to transfer these kind of labels 1,000 times. Yeah, and you can also specify which columns you want to include in the output. So let's include the ID again. Let's include the parameter name. Let's include the network name. Let's include the station ID and the station name. Let's also include the station type. And let's include the station population density. So if we do that, we get a somewhat longer list here. And in order to make this easier to read, let's actually go back here and restrict the search to the Westminster station. So station name equal London Westminster. Okay, so this is easier to read now. So we see as requested. We get the ID, we get the parameter name, we get the network name, we get the station ID, the station name, the station type, the station population density. And notice that the order of these columns is the same as in the request column here. So if we remove this as dict statement and return the response as an array again, we can be sure to know in which order the result is returned. So this gives us a search query, and very similarly you can also query for individual series. So that's the same kind of arguments here. You just replace search by series. The main purpose of this is again to identify the time series number. Well, we have one here already, so let's just use this one here in order to now retrieve values from it. So in order to do that, we use the stats command. Delete everything here. We write stats as a command, and then we type in a query where we simply say ID equal and then number. What this returns to us after a little bit of processing, remember that the program has to go into the database, retrieve all the hourly values and compute these statistics online as we file the request. And what this returns to you as a standard response is, again, a structure, a dictionary here, which lists first the datetime flags, and they're actually monthly in this case by default. We get values, the mean values of the series. We get the standard deviation of these mean values, and we get the count, so how many values we have in each month. Plus, on top of this, at the end, we get the metadata for the station. So you can see all kinds of metadata information about the time series and the station here. Now, of course, as I demonstrated to you in the use of the web interface, there are many more options for calculating various statistics and metrics, and these are accessible via the REST interface as well. So what you can do is, for example, specify the statistics which you want by typing statistics equal, and we can do, for example, daytime average here, and we could, for example, specify the daily maximum 8-hour average as DMA8, and then we have to on top of that specify whether we want this based on the US EPA definition or the EU definition. Let's use EU for this demonstration. And what happens after a little bit of processing, we see the response. Again, we get the daytime labels here. Here we get the daytime average values, and then here we get the DMA8 EU values, and then again the metadata at the bottom. Of course, you can also specify which kind of sampling you want. So the default is monthly, but if you want this for summer, we simply type in sampling equals summer. And again, it computes the statistics online, and here we go. And obviously, this is of course much shorter, much less data than in the monthly query. So this is the principle by which this works. And again, I can only encourage you to take a look at the documentation shown here at the base URL. And just to wrap up, basically, the different query commands that you can apply to this REST service are listed here. So it's parameters and networks, stations, series, search, and stats. And here's a general description of the query arguments. The response is typically JSON. In principle, you can also request HTML instead. Yeah, and then basically in section 2 of the documentation you get the individual descriptions for the different commands. Just to close, one recommendation: if you write your own programs to use the REST interface, it was a good idea to first try out the query that you want to issue via an interactive web browser, because it's very easy to make a typo or somehow misspell or mismatch one of the query arguments, and this can be fixed and corrected much easier interactively than by a program. Please note also that if you do issue many queries to the database, we do restrict the number of requests coming from a single user. So don't be surprised that at some point the responses might get a little slower and you will not retrieve results as quickly as you maybe hope for. In these cases, if you really want to do massive data downloads, please contact us and we can see if we can make these data available to you in a more efficient manner. Also note, please, that as I pointed out to you in the other tutorial on the web interface, and I'll just go back to the main site here, that we do have these precompiled metrics datasets available on the Pangea archive, and I would argue that in many cases these might be good starting points for the type of analysis you would like to do, especially for just sort of developing a feeling of what the data are like that you find in the TOR database. Thank you.